Now we're going to talk about the second kind of conduction. There went another nail. Or the second kind of heat transfer, rather, which is not conduction, but what? Everybody. A little louder. Yeah, now convection is another way that heat gets transferred. And it's the way that heat gets transferred through liquids or gases. Because liquids and gases are not good conductors of heat. But they do transfer heat very well. They use a different method. It's called convection. If you guys can just bring up that hot and cold water, I'll show you what we mean here. Yeah, thank you very much. That's cold. This is hot, eh? Kevin, could you get me just a little more water in there, please? Any temperature, doesn't matter. I'm watching that sixth nail there. Okay, I need those people from rows 4 and 5 to come up and stand right here, shoulder to shoulder, facing the north wall again. Okay, now you people are not metal this time. Can you move farther down, Bonnie? So Cindy doesn't catch on fire here? Okay, good. Now you people are not a piece of steel this time. Now you're water. Now water transfers electricity in a different way. It's by convection. And this is how it happens. If I give heat to you and you're a molecule of water, as soon as you get hot, you get out of the way. And you go way down there to the other end. And then that lets you come up and you're cold. And I give you some heat energy and you go down to the end. Cindy, you have to get right on the end with Bonnie there. Okay, Tammy, there's your heat energy. Heat energy. Heat energy. Keep coming, you cold people. Keep coming. Okay, now everybody's about the same temperature, right? But what happens is Cindy comes back and she's just as warm as everybody else. And so now she gets 2 cards. Now you're hotter. So you just keep going. This is how water and gas heats up. It doesn't conduct the heat energy down the line. The molecules move and come and get the heat. There we go. All right. Now we just keep heating this water and this air or gas up until it gets hotter and hotter and hotter. Do you see the difference between conduction and convection? How hot are you now? How many cards do you have? 5. Okay, I'm almost out of cards here. My fire's almost out. Oh, that's it. Fire's out. And that's how hot you are. Now you should understand that this is how heat... Hey, all the nails have fallen except for one. Were you watching them? Yeah. They must have fallen when we weren't paying attention here. Ooh, hey. All right. Here's some cold water. There's only one problem. We're running out of space here, aren't we? Indeed. Uh-oh. Move this flame. Put the fish bowl right here. This fish bowl is full of cold water. And now let's see. Kevin, did you find that little tiny bottle? Yeah, would you bring that up, please? Would you fill it with hot water? Oh, wait, I have some hot up here. Just bring it up. Yeah. No, what did I do with that? Food coloring. Did I lose it? Food coloring. Yes, yes. Food coloring. Great. Thank you, Greg. Okay, we're going to put a little food coloring in this tiny bottle so that we can see what's happening with the liquid. This is a liquid, and it'll get heated up by convection. Where's the hot water? Here it is. Okay, I'm going to fill this little bottle with hot water. Hot red water, in fact. Now I want you to watch carefully and see what happens to this hot red water in cold fishbowl water. Watch it carefully. You'll be able to see what it's doing. What is it doing? Can you explain it to me? Our last nail just fell by conduction. Where is the hot water going?
Out.
Greg?
Top of the surface.
Yes, it goes to the surface, and that's a principle of convection that you have to understand. The hot water goes up and cold water falls down. So if I put a fire under this and this was a pot of water boiling on a stove, the hot water that would get hot down here on the bottom of the pot would move up to the top, and the cold water would come down and take its place and then get heated up. Then come up and it would cycle around like that, just like we did with the cards. And that's how convection would heat up water. I want to show you another thing here, a neat example of convection. And Kevin, I need this topped off with hot water again. Sorry, I keep you running around, don't I? That's the... Okay, now this is cold water here. This is kind of a neat thing in itself. If I want to keep this cold water in here, I can just take an ordinary card, place it on top here. Now, do I dare turn this over? Ooh, I don't know. Yeah, okay. There we go. Now we have some cold here, some hot. I want the cold to be on top this time, and the hot to be on bottom so we can see this convection of heat energy. Add our food coloring here to this warm water. We want to put a lot in there. Okay, now we have some red water on bottom. And are you all clear on what temperature this water is? What is it?
Hot.
Yeah, this is hot. And this is what?
Cold.
Now where does hot water want to go? It wants to go up. It wants to get out of the way so the cold water can go down and get heated up. Now if I can just match these two up. Whoops. Well, I just spilled a little bit of cold water, didn't I? Ooh, this is very, very tricky. Oh, well, do you want to come up and sit carefully on the floor again so you can see what this is doing? Now, can somebody explain to me what's happening? I want you to look real closely right here and tell me what's happening. Okay, let's go with hands because it sounds kind of confusing here. Carrie? What's happening here? Yeah? And how is it getting up there? Like if the hot water goes up, how can the cold water get by there? Bonnie? Okay, yeah, it seems to be some kind of sucking, pulling, drawing action in there. Ashley?
And it also, when it tries to get up, the cold water is pushing down and it pushes so both the hot water is real hot and the cold, when it pushes right through.
Yeah, that's right. It does push through. The cold pushes down, the hot pushes up, and you can see it churning and bubbling right there in the middle. That happens in ocean currents. Some water in the oceans get nice and hot around the equator. And then they have to move out of the way so that the cold ocean currents can come in and take their place. And so oceans are constantly shifting and churning so that the cold water can come in and take the hot water's place. Same principle that we've learned here on convection. Okay, neat. All right, you can take your seats again. Thank you. Yeah, don't bump it, by all means. Maybe I better set that back down now so it doesn't fall. Okay, heat travels through matter in two ways. Raise your hands, but don't say it. Who knows one way that heat travels through matter? Raise your hands, don't say it. Think. One way. One way. Okay, tell me the way you're thinking of first. Everybody. Okay, conduction. Now, who can describe conduction in about 10 words? 15 words. Okay, Tammy, go ahead. A little louder.
When the heat and the
Rod.
The rod, when the lights got down.
Yeah, okay, right. Yeah, one by one those nails fell off, and that shows conduction. It shows how the heat conducts down the rod and melts the wax. Good. Okay, now raise your hands if you can think of the second way that heat is transferred through matter. Okay, say it. Convection. Okay, who can describe convection? Only Tammy again. Nobody wants to describe it. Okay, Christy, go ahead.
It's like water, like that. There, and the hot water wants to go up so that the cold water can go down.
Okay, good, yeah. Hot water wants to go up so that cold water can come down and take its place. That's convection, good. Great. Now, who can tell me, if we took different kinds of matter, let's say copper, what way does copper transfer heat? By convection or by conduction? Think for a second and then tell me out loud. Everybody get ready to say it. Copper. Ready? Go. Conduction. Okay, good. How about air? Yeah, it's convection. It works like water. I didn't explain that too much, but that was good. Water and air work the same way. They both work by convection. Okay, how about Kool-Aid? Convection, yeah. And how about the steel in a railroad? Conduction. How about when you're cooking soup on your stove? How does the soup get heated up? Yeah, by convection. Good. Okay, hey, good. I'm proud of you. Well, that's it for today. And next day we'll do some more experiments with heat transfer. And I'll show you some neat things. Now that you understand those two principles, I can show you some really fun experiments.
Hi again. We hope you enjoyed our show on heat transfer. My name is Kelly Wolf, and
my name is Tammy Moraz.
if you have any questions, please write to
Mr. Walters, Box 1562, Innisfil, Alberta, Tom 1AO. Thank you for watching our show.
See you next week on Science Fun.